All right. Hey, Block. I hope you're doing well. I'm going to go over this first example, which is going to show you how to solve with elimination. So you might be thinking, Ms. Loneck, I have no idea what you're talking about. So if we back up, the whole concept of systems of equations is all about really finding the intersection point of a graph. When you graph two lines, you're finding the intersection point. We did it a little bit in Shark Tank. Um, some other methods to find the intersection point, if you aren't able to make a graph, like if you don't have the ability to use decimals, the other ways that you can go about finding the intersection point is by using the substitution method or the elimination method, which we're going to learn today. I'm going to show you how to do it. All right, so this first example to solve with elimination requires you to do 4 steps. Elimination requires you to identify which variable has the opposite coefficient. Adding the equations together, you add them together, it will cancel out one of the variables, or at least it should. Then step 3 is to solve for the other variable, and step 4 is to plug in to find the first variable. So don't worry, if none of this makes sense to you, I'm going to go over an example and it will become clear. I'll show you how to do the steps with this example. So the example we're looking at is x plus 2y equals 3. That's the first equation, the top equation. The bottom equation that we're using is 2x minus 2y equals 9. Again, the whole point is we want to figure out what x and y are the intersection point of these two lines if we graphed them. Okay? So step 1 is to identify which variable has the opposite coefficient. When we say opposite coefficient, that's like if I want to find, if I'm comparing the x's in both equations, one of them is a positive x, the other one is a negative or a minus x. Another classic example would be if you had a positive y in one of the equations and a negative y in the other equation. If we compare these two equations for this example, if we compare them, you might notice that looking at the y's, that something funny is going on. You probably noticed that the top equation has a plus and the bottom equation has a minus. And even more than that, the top equation has a plus 2y and the bottom equation has a minus 2y. It's plus 2y minus 2y, that the 2 is the same and that they're opposites. One's plus, one's minus. So as far as step 1 goes, opposite coefficients, in this example, the variable that has opposite coefficients is the y variable. Okay, so step 1, done. Step 2, add the equations together to cancel out one variable. And you might think that's crazy, but we're quite literally adding the equations together. So to do that, I'm going to try and use some color coding. We're going to add the x's together. I don't know why my coloring isn't working. We're going to add the x's together. We're going to add the y's together. And we're going to add the plain numbers together. We're adding them together. That's what step 2 is asking you to do. Combining like terms, you could think of it as. Okay? When we do that, I'm going to switch to the blue. When we do that, you might notice x and 2x are going to combine together. That's going to give me 3x. There's an invisible, even though it's not written, there's an invisible 1 in front of the x. So when I add 1x plus 2x, that's going to get me the 3x. Okay? The other thing you might notice when we move on to the next one, plus 2y and minus 2y, think about it. If you had a positive 2y minus 2y, 2y minus 2y, if you combine them, that's 0y. In other words, the y's get eliminated. That's why it's called the elimination method, everybody. Because they get eliminated, I don't need to include the y term below. I don't need to write anything related to the y. After that, the next thing we're going to do is write equals, and 3 plus 9 equals 12. So let's review. We added the x's, we added the y's, We added the plain numbers. We end up getting 3x equals 12. So finally, the next step that we can move on to, now that we've added the equations together, we can now solve for the other variable. What that means is, for step 1, we found out which variable has the opposite coefficient, and that was the y variable. So for step 3, solving for the other variable, that's really asking for us to solve for the for the x variable. Cool, which is what we have. In order to do that, we're going to divide both sides by 3. Divide both sides by 3. 3x divided by 3, those 3's cancel out, which means that we are left with just an x on that left-hand side. So x equals, and then we're going to do 12 divided by 3, which is 4. So we just did step 3, which is solve for the other variable. We solved for x. Great job. We end up getting that x equals 4. Okay, so hopefully this is making sense so far. The last step we need to do is plug in to find the first variable. In order to do that, we're going to need to plug this 4 in place of the x into one of those two equations. It honestly doesn't matter which one we use. Sorry, my writing is a little delayed. It doesn't really matter which one we use. We could use the top equation or we could use the bottom equation. Doesn't matter. You'll find that whatever one you want to replace and plug in for the x, doesn't matter. You'll get the same answer. So let's do it. Let's plug it into the top equation. The top equation, it was, when we originally used it, x plus 2y equals 3. Now that we know x is 4, we can replace the x with a 4. So we get 4 plus 2y equals 3. From here, we can subtract 4 from both sides. So minus 4 on both sides. We end up getting the 4's that cancel out. So we are left with, on the left-hand side, 2y equals 3 minus 4, which is negative 1. From here, to solve for y, to finish it up, divide both sides by 2. Divide both sides by 2. I don't know why it's delayed. Oh boy. When we divide both sides by 2, we end up getting y equals negative 1/2. So let me type it. Y equals negative 1/2. Cool. We found out what y equals. So we have what x equals. We have what y equals. The final answer, if you remember when we learned how to write them in a professional way, the final answer is 4, negative 1/2. Whoa, negative 1/2. You might remember when I first, introduced this whole concept of solving systems of equations, I told you guys that no matter what method you're using, the concept is the same. When you are solving a system of equations, you are always finding the intersection point on a graph. So if we looked at a graph of these two equations, x plus 2y equals 3, and 2x minus 2y equals 9, if we graphed those and looked at their equations on a graph, take a look. Let me clear my notations. Take a look. Whoa. On this graph, guess what? The intersection point is 4, negative 0.5, negative 1/2. So the answer should be the same as what we did when we used the elimination method. I hope this example helps, and if you need to, rewind it, pause it, whatever you got to do, rewatch it as much as you need to in order to understand what you have to do to use the elimination effectively.